You ever wonder what those pinholes you often see in concrete floors are from? Well, that's from concrete outgassing. This refers to the phenomenon where air and water vapor trapped within concrete escape through its pores and capillaries. This process occurs due to the changes in temperature and barometric pressure. Concrete is inherently porous, resembling a hard sponge. It contains microscopic voids and capillaries that allow air and moisture to flow through during pouring and placement of the concrete. Air entrainment, or intentional introduction of air voids. This improves concrete's freeze-thaw resistance. Outgassing occurs when air expands and releases itself through concrete pores. As temperatures increase, air moves in and out of concrete, eventually reaching the surface. Moisture vapor transmissions, or MVT, often accompanies the escaping air due to the concrete's sponge-like nature. Surface coatings, such as epoxies, urethanes, and other concrete overlays, act as barriers against water and chemicals. When applied to a concrete surface experiencing outgassing, the trapped air causes defects or pinholes in the coating. Coating defects can render the coating non-functional for its intended use. To prevent any coating defects, properly clean the concrete surface before coating application. Monitor environmental conditions such as temperature and airflow during the coating application to prevent outgassing and defects. Addressing concrete outgassing is crucial for achieving durable and effective coatings on concrete surfaces. Earlier, I briefly mentioned air entrainment. This is when tiny air bubbles are introduced into a concrete mix during the mixing stage. These microscopic air bubbles serve several important purposes, one being freeze-thaw durability. Air entrained concrete contains a network of these tiny air bubbles. When water trapped within the concrete freezes, it expands. The presence of air bubbles provides small pockets for this expanding water to occupy. By accommodating the expansion, air-entrained concrete helps alleviate internal pressure caused by freezing and reduces the risk of cracks. A single cubic foot of air-entrained concrete may contain billions of these air bubbles, significantly impacting both fresh and hardened concrete properties. It also helps with crack prevention. Without air entrainment, water has no place to escape when exposed to freeze-thaw conditions. In the absence of air bubbles, the internal pressure from freezing water can lead to cracks and scaling in the concrete. When trying to achieve air-entrained mixes, application consideration is very important. Air-entrained concrete is ideal for projects where the surface will be exposed to freeze-thaw cycles during winter months. Even in milder climates with occasional freezing temperatures, using air-entrained concrete is a safe choice. However, it's essential to note that air-entrained mixes are not suitable for all purposes. For surfaces that require a slick finish, achieved by steel trialing, which is most of the concrete microtopping overlays, non-air interior mixes are recommended. In summary, air entrainment enhances concrete's resistance to freeze-thaw cycles, helps prevent cracking, and ensures long-lasting structures. So now that we know the pros and the cons of air entrainment, let's go over how to prevent concrete outgassing. Preventing outgassing involves a combination of proper construction practices and thoughtful coating application. You want to start off with the proper surface preparation, and that's cleaning the surface. Before applying any coatings, ensure the concrete surface is clean and free from dust, dirt, oil, and other contaminants. We achieve this through the grinding process. Then we'll fill any voids or irregularities in the concrete. We use cementitious patch products to create a smoother surface and reduce the potential for outgassing. Then you want to wait for the right environmental condition. Here in Florida, it is blazing hot during the day year-round. So we want to lay our coatings either really early in the morning or more towards the evening time. If possible, you want to shield the concrete surface from direct sunlight during coating application. You can also apply a compatible primer to the concrete surface. The primer helps seal the surface and creates a thin film air block, reducing the chances of outgassing. And if you're installing a self-leveling overlay, you can use a spike roller to release any trapped air. Make sure you choose high-quality coatings. Opt for coatings specifically designed for concrete surfaces. High-quality coatings are less likely to develop pinholes due to trapped air. Always follow the manufacturer guidelines. Adhere to the manufacturer's recommendations regarding mixing ratios, application thickness, and curing times. Remember, the proper surface preparation, timing, and coating selection play a crucial role in preventing concrete outgassing. By following these guidelines, you can achieve durable and defect-free coatings on any concrete surface. If you find these videos informative, please throw a like on it, and if you're not subscribed, please consider subscribing. Thank you, and as always, have a great day.
Yeah, like my mixing job, leveling job.
You did good. Zach, you did good today.